Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, I have given you three presentations regarding lab activities and your performance, how you perform and what protocol you have to follow. Four major protocols are discussed with you that you will perform preliminary investigation. I have detailed told you about that and discussed about element detection, that how many elements you have to detect during this coursework, and then following functional group detection and derivative formation for confirmatory tests, and then how to report your result in your lab journal or lab notebook. So, coming towards the preparation of LASSAIGN solution or sodium fusion test or sodium extract. Three different names are used. This extract. So you have to detect these elements, namely nitrogen, sulfur, or simultaneously presence of nitrogen and sulfur, three halogens, chloride, bromide, or iodide. The detection of these elements depends upon converting them to water-soluble ionic compounds. You know, I told you that covalent bonds are non-reactive. Therefore, ionic compounds are used to visualize colors or precipitates, and it is easy for those compounds containing these elements. So how you prepare sodium fusion? How sodium is fused with organic compound to make it from less reactive to reactive organic compound. So organic compound is containing nitrogen. When sodium metal is reacted with organic compound, it is transformed into sodium cyanide. And what happens with sulfur? Sodium metal reacts with sulfur to form sodium sulfide. And if both sulfur and nitrogen are together present in that organic compound, sodium thiocyanide is formed. And sodium metal, when reacted with chloride, formed sodium chloride. If it is reacted with bromide, sodium bromide is formed, and when it is reacted with iodide, sodium iodide is formed. So I have given you equations. You have to write in your practical notebook adjust opposite in the reaction column. When you will write inference after observing, like benzoic acid is given, and when you treated benzoic acid with sodium bicarbonate, in observation column you will write effervescence. In inference you will write maybe carboxylic functionality is present, and in equation you will write that as I have told you before. Now, in when you have compound benzamide, when you have to write how LASSAIGN solution is prepared. I have given you above, and then you will write this for nitrogen, that you first made LASSAIGN solution, 5 to 6 lines you have to, and then you will write when you will organic compound plus few drops of sulfuric acid. Organic compound, from organic compound you have prepared sodium fusion extract, and you will add sulfuric acid, few drops, one or two enough, in the LASSAIGN solution. First you will prepare LASSAIGN solution, you will divide in 4 parts. For nitrogen, for sulfur, on one test tube you will write N, for second you will write S, for third you will write NS, and for fourth one you will write halogens for halides. When in first test tube you will put sulfuric acid in that LASSAIGN solution. If Prussian blue color is observed, you will conclude that nitrogen is present. You will write first this one. Cyanide will react with ferrous sulfate. Here, after adding sulfuric acid, you will put ferrous sulfate, and Prussian blue color of this complex is formed. This is the equation. Then for sodium fusion, it's in the second test tube. If above reaction is no color is observed, it means nitrogen is absent. Now you will come to the second test tube. In this sodium extract, you will add lead acetate, black PPT will be obtained. You will conclude that sulfur is present. And on adding lead acetate, violet coloration is produced. It means sulfur is alone present. Actually, sodium nitroprusside, violet coloration is obtained, and adding lead acetate, black color is obtained. These are two. Actually, here it is missing. Uh, it is black precipitates when treated with lead acetate, and when treated with sodium nitroprusside. Kindly make correction here. When treated with sodium nitroprusside, violet coloration is obtained. And here ferrous sulfate and sulfuric acid. Ferrous sulfate and sulfuric acids, these both are added and you get Prussian blue color, then nitrogen. And if adding lead acetate, black PPT, sulfur is present. Another test, sodium nitroprusside is added to LASSAIGN solution and you get violet coloration, sulfur is present. And in third test tube, if both these above are absent, negative, no coloration is observed, you take ferric chloride, few drops, add few drops of ferric chloride in sodium extract, a blood red coloration is obtained, it means nitrogen and sulfur, they are together present. They are present thiourea. In thiourea, sulfur, nitrogen, they are present in the same compound. For chlorides, if all above three tests are negative, means that negative test for nitrogen with sulfuric acid and ferrous sulfate, you didn't observe any color, no Prussian blue color, nitrogen is absent. For sulfur, if with lead acetate no black PPT obtained, sulfur is absent. If violet coloration with sodium peroxide is not observed, it means sulfur is absent. And if adding ferric chloride, blood red coloration, dark red coloration is obtained, it means sulfur, nitrogen both present in the same compound. And if there is no blood red coloration on the addition of ferric chloride, it means sulfur, nitrogen both in the same compound are not present. So you come towards halogens. During preparation of LASSAIGN solution, sodium chloride is present in that LASSAIGN solution. On introducing silver nitrate and adding few drops, 1 or 2 enough nitric acid, you will get white curdy precipitates, emulsion like curd. And if you don't observe curdy but rather you observe pale yellow precipitates, it means bromide is present. And these pale yellow precipitates are soluble in ammonia. When you get yellow PPT, good color of yellow PPT, not pale, beautiful color of yellow, it means iodide is present. And there is discrimination if there is someone not uh, sure that these are bromide precipitates or iodide precipitates, and it is simple that if PPT, this is confirmatory test for chloride, those curdy PPT, if you put sodium hydroxide, these will be soluble. And in pale yellow PPT, ammonia is uh, introduced, yeah, ammonia is added, ammonia solution, those pale yellow PPT will be solubilized. And for iodide, if you take sodium extract and you put few drops of carbon tetrachloride, two layers will be formed. And if we add chlorine water, we will observe violet coloration. It means that iodide is present in the given organic compound. So kindly make correction here. In nitrogen, sulfuric acid plus ferrous sulfate. Prussian blue color appears, nitrogen is present. Sulfuric acid plus ferrous sulfate. Here is mistake. And here mistake that lead acetate, black PPT, sulfide is present, and here it should be sodium nitroprusside. it was sodium nitroprusside like this, and we get violet coloration, sulfide is present, and with and blood red coloration when ferric chloride is poured into the sodium extract. And for these PPTs, 3 PPT, Kurdi PPT with, you have to take silver nitrate for these 3. If you get white curd like precipitate so easy, chloride is present. Here discrimination is difficult, that pale yellow or yellow, so it is easy. These are soluble in ammonia, and this one, when you add carbon tetrachloride, 2 layers appeared, and on adding chlorine water, violet color is very clear. It means you can confirm that which one of these elements is present in the given organic compound.